Hi students, welcome to the video lectures of heat transfer subject. Today we are going to cover the topic of heat exchangers from module 5. So first we'll study what is a heat exchanger. Heat exchanger is one of the most commonly used process equipments in the industry. And the function of this heat exchanger is to transfer energy. Let us define this heat exchanger. Heat exchangers are the devices in which heat is transferred between the two fluids at different temperatures without any mixing of the two fluids. As we already know that heat always flows from high temperature medium to the low temperature medium. So here in this heat exchanger, heat flows from hot fluid to the cold fluid. So next we will study the types of heat exchangers. So broadly, these heat exchangers are mainly classified into these three types. So one is direct transfer type heat exchanger. Second one is storage type heat exchanger. Third one is direct contact type heat exchanger. We'll study one by one. First, we'll study direct transfer type heat exchanger. This direct transfer type heat exchanger is one in which both hot fluids and the cold fluid flow simultaneously through the device and the heat is transferred through a wall separating the two fluids. So you can see the sketch here. So this is an example of the double pipe concentric tube heat exchanger. This is an example. You can see here sketch. Why it is also called as the double pipe concentric tube heat exchanger? Because one tube is placed in the another tube. This is one tube and this tube is placed in the another tube. So here the hot fluid is flowing at the left end of the heat exchanger and it is moving towards the right, and this hot fluid is exiting at the right end of the heat exchanger. Whereas cold fluid, it is also entering simultaneously through the annulus of this tube and it is also flowing along the length of the heat exchanger, and this cold fluid is coming out at the exit of the heat exchanger. Here the heat transfer from the hot fluid to the cold fluid, it takes place across these walls of the inner tubes. Heat transfer flows across the walls of the inner tubes from this hot fluid to the cold fluid. Here the two fluids are not going to mix each other. They are separated by the wall, solid wall. So next we will study the type storage type heat exchanger. The storage type heat exchanger is one in which the heat transfer from the hot fluid to the cold fluid occurs through the coupling medium in the form of solid matrix. The hot and the cold fluid flows alternatively through the matrix. The hot fluid storing heat in it, and the cold fluid extracting heat from it. So the example for this storage type heat exchanger is single matrix storage type heat exchanger. So this is the sketch of the storage type heat exchanger. So in this sketch you can see the marks inside. So these are nothing but the matrix. It is a porous matrix. This porous matrix, it may be in the form of the bricks with the small holes in it, or this porous matrix, it may be a small loosely filled material pieces. That means the fluid, when it is entering the matrix, the fluid should flow through the matrix. There should not be any obstruction. So it is called as the porous matrix. So in the process, so these are the walls. You can see here, this is the circle with cross marks. These are called as the walls. So initially, this wall A and this wall B are kept open. Both this wall A and wall B are kept open. At the same time, this wall C and wall D are kept closed. So through this wall A and wall B, where the hot fluid is entering through this wall A and wall B, whereas through this wall C and wall D, the cold fluid is entering. So initially, the hot fluid is made to pass through this porous matrix material. So where it is hot fluid, it gives up its heat to this porous matrix material, and this porous matrix, it is storing the heat which is received from this hot fluid, and the hot fluid is going out through this wall B. So this process is continued for some time. Then afterwards, this wall A and wall B are kept close, and then this wall C and wall D are kept open. Now the cold fluid, when it passes through this porous matrix material, this cold fluid, it picks up the heat from the matrix material, or this cold fluid, it is extracting the heat from that matrix material, because the heat is stored in this matrix material which is received from the hot fluid. So this cold fluid, when it extracts heat from it, this cold fluid gets heated and it is passed through this wall D. So this process, it is again carried for some time, and again both these walls are kept closed. Again we are going to open these two walls A and B. So this process continues, where heat exchange takes place from the hot fluid to the cold fluid, where heat is stored up in this matrix material, and it is that stored heat is extracted. For that purpose, it is called as the storage type heat exchanger. So now last one, we will study the direct contact type heat exchanger. It is the one in which the two fluids are not separated. So here in both the previous examples, the two fluids were separated. They are not mixing with each other. But in the direct contact type heat exchanger, these two fluids are mixed with each other. They are not separated. If the heat is to be transferred between a gas and the liquid, either the gas is bubbled in the liquid or the liquid is sprayed in the form of fine droplets into the gas. So in this example, here the liquid is sprayed in the form of fine droplets into the gas. Gas, here we are treating it as the air. So this is the best example of the cooling tower which is used in the power plants. It is as well as used in the cogeneration section in the sugar industries also. So in the cooling tower, where this hot water is sprayed at the top in the form of fine droplets. So at the bottom of this cooling tower, where the cold air is forced to move upside. So when this hot droplet of water, when it comes in contact with this cooled air, where heat is transferred from this hot water to this air, and where water gets cooled, and after transferring the heat from the water to the air, this air gets heated up and this warm moist air is taken out at the top. So here you can see here both this droplet of the hot water, it is coming in direct contact with this air. For that purpose it is called as the direct contact type heat exchanger, where heat exchange takes place from the hot fluid to the cold fluid directly. Both these are mixing with each other. So after cooling the water, that water is collected in the tank and it is taken out for further process. So next, this in the we'll study the cell and tube heat exchanger. This is the another type of the direct transfer type heat exchanger. So again, these direct transfer type heat exchangers are again classified into tube heat exchangers, plate heat exchangers, and based on the direction of the fluid flow in the heat exchanger, again these heat exchange direct transfer type heat exchangers are classified as parallel flow, counter flow, and cross flow. We'll study it next. So now we'll study cell and tube heat exchanger. So it is a type of the tube heat exchanger which falls under the category of direct transfer type. So this is the sketch of the shell and tube heat exchanger. The best example for this shell and tube heat exchanger is the condenser, which is used again in the power plants, where condenser is used to condense the steam. The main components of this shell and tube heat exchangers are tubes. These are the tubes where one type of fluid is entering in the tubes, and this is the shell. This entire thing outside portion of the tubes, it is called as the shell. This is second component. Third is the tube header sheets. This is the tube header sheets where tubes are going to be fixed in these tube header sheets. Next one is the important component is the front end header, and this is the rear end header of this shell and tube heat exchanger. Fourth one is the nozzles. I'll tell you what are nozzles, and next one is the baffles. So now usually in the condensers, this is the tube inlet. Tube inlet means one of the fluid it is entering in the tubes here. These are the tubes, one of the fluid which is entering in the tubes. So for that purpose it is called as the tube inlet. So it is entering here and the fluid is passing in the tube outlet. That means one fluid is entering here and the another fluid is entering in the shell side. That means over the surface of these tubes another fluid is passing. So usually in the heat exchanger, cold fluid, that is water, will be passing inside the tubes, and whereas steam is passing over outside the surfaces of the tubes, in which the water is flowing inside the tubes and outside the tubes where steam is passed. So where heat exchange takes place from this steam to the water where steam gets condensed. So now we'll study next. So these valves, tube inlet, tube outlet, shell inlet, shell outlet, these are called as the nozzles, or these acts like a nozzles. Next component is the baffles. So these baffles are the thick sheets which are provided inside the shell. So these baffles are provided in order to move the shell side fluid over the surface of all the tubes, so that it can change its direction, and it should move over all the tubes in order to increase the heat transfer area, or in order to increase the effectiveness of the heat transfer. If these baffles are not provided, then the shell side, the fluid may come here and directly it may go out from here, so that heat transfer will not be effective. For that purpose, these baffle plates are provided. So next we will study these the different types of direct transfer type heat exchangers, which are classified based on the fluid flow directions. So already I have told you. So based on the fluid flow directions, these direct transfer type heat exchangers are classified as parallel flow heat exchangers, counter flow heat exchangers, and cross flow heat exchangers. So now we'll study one by one. So this is the parallel flow heat exchangers. So in parallel flow heat exchanger, so this is also a double pipe concentric tube heat exchanger only, because one tube is placed over the another tube. So this is one tube, this is another tube. So in the parallel flow heat exchanger, the hot fluid and the cold fluid flows simultaneously in the heat exchanger, and the direction of the hot fluid and the cold fluid are in the same directions. So you can see here the hot fluid which is entering the heat exchanger at a temperature of TH1, where T indicates temperature, the subscript H indicates hot fluid, the subscript 1 indicates hot fluid is entering at the inlet of the heat exchanger. The hot fluid is moving along the length of the heat exchanger, and it is hot fluid is moving out here. You can see here the temperature of the cold fluid, it is indicated as TC1, where T indicates temperature, C indicates cold fluid, 1 indicates at the inlet of the heat exchanger. Here the cold fluid is passing over the annulus of this tube. Here both the hot fluid and the cold fluid are flowing parallel to each other and in the same directions. So we can explain more here with the help of this graph. So on the y-axis, the temperatures of the fluids are plotted, and this is the length of the heat exchanger. So you can see here TH1, this is TH1. So when the fluid is entering the heat exchanger, it will be having the high temperature. For that purpose, it is plotted here, temperature. So when it moves along the length of the heat exchanger, this hot fluid, it gives up its heat to this cold fluid, where heat transfer takes place across the walls of these inner tubes from the hot fluid to the cold fluid. So when the heat is transferred from this hot fluid to the cold fluid, its temperature goes on decreasing. For that purpose, the graph is shown in the decreasing side. The temperature goes on decreasing when the hot fluid moves along the length of the heat exchanger. See here. Whereas the temperature of the cold fluid, it goes on increasing when it moves over the length of the heat exchanger, because this cold fluid, it is receiving heat from the hot fluid. This hot fluid, it gives up the heat whereas this cold fluid, it gains the heat from this hot fluid. So you can see here this temperature of the cold fluid, as it gains heat, its temperature goes on increasing along the length of the heat exchanger. So next we'll study counterflow heat exchanger. So in this counterflow heat exchanger, here also both hot fluids and the cold fluids flows simultaneously and parallel to each other, but both the hot fluid and the cold fluid, they moves in the direction opposite to each other. So you can see here hot fluid is moving from the left to right, whereas cold fluid is moving from right to left in the heat exchanger. For that purpose, it is called as the counterflow heat exchanger. In the counterflow heat exchanger, both hot fluid and the cold fluid flows simultaneously and parallel to each other, but the directions of these hot fluid and the cold fluid are opposite to each other. So you can see here in the graph, the temperature of the hot fluid, it goes on decreasing when it moves along the length of the heat exchanger, because this hot fluid, it is giving up the heat to this cold fluid. So in the counterflow heat exchanger, cold fluid enters from this point and it is moving along the length of the heat exchanger in the opposite direction to the hot fluid. So here also you can see the temperature of the cold fluid, it goes on increasing when it moves along the length of the heat exchanger. So next type, last one, we will study cross flow heat exchangers. So in these cross flow heat exchangers, both hot fluid and the cold fluids are moving at right angles to each other, or they are moving at perpendicular to each other. Here you can see the hot fluid unmixed stream we have shown here. That means the hot fluid is flowing in the tubes separately. It is not mixing with each other, and it is hot fluid is taken out from here. But this cold fluid, it is in the mixed hot stream. That means the cold fluid is mixing with each other here. That means the temperature of this cold fluid, it is not uniform along the length of the heat exchanger. So you can see here another example of the cross flow heat exchanger. Here both hot fluids and the cold fluids are not mixing with each other. They are flowing separately here. See here, hot fluid unmixed stream, whereas cold fluid is also unmixed stream. So the temperature of these fluids, it may vary along the length of the heat exchanger. The temperature may not be uniform. So this is about the brief introduction about the heat